Let me check the mailbag. Check in the mailbag. Check in the mailbag. I'll be bringing, if anyone's here yet, I'll be bringing the screen back in a minute. We're just doing high security email. Repro case. Okay, we turn the screen on now. Had my stream still open? Well, why is my stream not on your computer 24? Why is my screen? Okay, look, in Windows, you go to the menu and they have like Candy Crush in there and stuff. So like in Windows 11, you should open the start menu and they'll just have my stream right there. Right? Right? I heard Satya Nadella say that that was what they would do. Okay. So we have multiple problems. First is that this code does not work. Second is that we're not saying, we're saying quadruple question marks, which is not good for the type. Who even says that? Like, this is typed to string. I don't even know where that comes from. Print asked. What? Why are we there? Add parameter string? I know I made this. This isn't someone else's, but I don't understand why. Oh, because this isn't for types. Wait. Wait. Baked literals match. What? Why are we there? Return A. Incompatible specifications. Oh. Interesting. Okay. I'm not sure how... Okay, I get what he's doing. So... Right. Baked literals match exactly. So we want to go there. But here we'll say, for code, we want to say... Okay. So we're fixing the question marks first. Unknown location. Undesignated, because it's probably your fault if that happens. Okay. Okay. Code directives. I guess they're literals. I don't know. Okay. So we haven't yet made it that they match yet, but there we go. Code at here got code at the same line because it is the same. Okay. The parentheses are maybe confusing. But I don't think we should put these. Like what I've been learning is that the punctuation is not really helping. Okay. Now, dang it. Just view cryptic errors. Yeah. Yep. Hey, it works. Let's make it different. Let's make it not work. So if we return B, it'll say we wanted cond of code equals line 11, Oh, because we're giving, oh, yeah. We want cond of B. Why is it saying type given type? Oh, because I'm returning a freaking type. Guys, sometimes I'm dumb. Not always. There we go. That's what I want. Type wanted cond of this given cond of this other code that is on a different line. And maybe the parentheses are not that helpful. We can explore some other day better punctuation. But in the meantime, this is the information that you need to solve the problem. Okay. Return A. So we are back to this working. And I'm going to put this in test regression grab bag. And we're going to say there. Okay. Oh, grab bag. Cool. Why does it want line 12 but given line 6? That wasn't backwards. No, because the declared return type was cond of this, which was passed in from this thing on line, probably line 12 at the time. But we deleted the 3 lines that were in here. So code has to be code that is instantiated at the same location. No, it just has to be known. It has to be known constant at compile time. And there are a number of ways that that could happen. Does known at compile time mean the result of the code? If you mean the result of the code running, no. No, you just have to know what the code is at compile time. Yeah, this is just a dumb, this is obviously not anything that anyone cares about. This was just a repro case, you know, to show that something wasn't working that should have worked. Fixed code literals not matching themselves for the purposes of polymorphic type comparisons. Okay. Okay, I go over here and I go to the person and I say fixed in the next beta. Also, the error message is more helpful if someone makes the actual error. Okay, that was really all I wanted to get done tonight. So we'll see what else happens. Oh, good. I pushed send on my Gmail and it's just sitting there not doing anything. Let's see this one. I suspect that this person is incorrect about what they are sending me, but we will verify. We will verify. We will verify. Okay. Code struct notes extracto mundo. Extracto mundo. Did I? Okay. I just don't. Oh, there we go. Okay. Let's see. Oh, maybe not. Maybe it is my problem. Test has note annotation C. Test has note annotation A. Declarations are, okay. So, yeah, he's saying, okay, we're going in, we're looking at the messages, and we're looking at the notes array on the struct. It appears to not be filled out. Print hello world ends equals double quote. Why does this code not work? It does not work because you didn't enable floating point exceptions. No, I don't know. I don't actually know what ends equals double quote means. I don't know what programming language that is. You can't ask that question from anyone unless you actually tell them what programming language it is. So your school book says that. Well, how does it not work? What does it say when you try to do it? This is Python 3. Okay, somebody knows. Somebody knows what it is. So maybe there's a typo in the book, and the book says ends when you want end. Visual Studio to stop displaying code for you. That's because you need to use Visual Studio Code to display code, all right? Regular Visual Studio nothing displays nothing, but Visual Studio Code displays code. Get with the program. There'd be an error indicating ends was wrong. Yeah, but the person reporting this hasn't yet said what actually happens when this is tried. So we don't know if it says that ends was wrong or not. I've never actually seen Community, so maybe I should try Visual Studio Community. So what school is this that you are learning this at, supposedly in a week? This one in Ireland. Well, maybe they need to check what books they give you. I guess that's obvious. Okay. Let me see if we're even trying to do this. Export notes on a declaration, on a procedure, on a struct. Does this mean that we don't actually... It might be that we pull them off the struct and put them on the declaration somehow. It does sound like a very bad teaching technique. I would be super annoyed at how much of my time was wasted by that. If it's intentional. But I bet it's not intentional. I bet it's just very careless. Okay, so when we parse... Parse notes. This is probably the struct case, right? Oh no, that's the declaration case. Here's the struct case. So we do parse notes. That's why this parses, of course. Do we ever clear that? Yes. Do I do that for procedures too? Nope, just for structs. Well, that is clearly not the right thing to do anymore. If it ever was, which it wasn't. Hey, okay. So, fixed structs resetting their notes arrays when passing them to... I didn't even check in the frickin' previous thing, huh? I'm just doing I'm doing a multi-ball pinball machine. All right. This is fixed in the next beta. Structs were just their notes arrays after passing them off to... For some reason, this might have been a guess about how things... This was a guess about how things should go, but made a long time ago, and now it's clear that it's the wrong thing. Okay, boom. Fixed. Okay, so now we come to the biggie. Hold on, let me check this in. So here we come to the biggie, which do I do it right now? I should put all these. Boom. So the biggie is the following thing has been reported, that maybe our operator precedence between bitwise and not is maybe not very good. And it's a scary thing to change because it'll break people's programs. But the sooner we change it, the better, right? This is kind of a hack introducing a bug. Yeah. Well, this part didn't introduce the bug though. And that's what I was talking about. So I don't know. Did we not discuss it at length and figured it was good? Did we? I don't remember. It's different from C right now. Let's go back and just look at it, right? So we have, I don't know, A is a U8 that's equal to 80, or 8, let's say F0, right? B is a U8 is 1F, right? So they overlap by 1 bit. C is not A and B, right? This looks to me, if you just write that, that looks like not A and B, right? But I believe it's E. Yeah. You would expect the first one. Why? Like, if we talked through this a long time ago. Oh, you mean, by first one, you mean this? Yeah, okay. So I think maybe I do vaguely remember some discussion about precedence, but it might have been not relative to some other operator. Not as like unary minus. Right. So if you say like -5 plus 7, that should be 2. Let's... F is -5 plus 7. Right? Yeah. So I agree that that should be, and plus is like or, not really and, but you know, whatever. Yeah, now this is scary because some code might be wrong somewhere, but hopefully people just put parentheses if they were confused. I could have the meta program scan for this. Imagine building an entire game with a broken unary minus. I bet you somebody's done it. Like, of all the games people have made in whatever broken-ass scripting languages and whatever. I mean, maybe not a game of this size, but... How much would it hurt to just force users to specify? You don't want to do that. You want to make it good by default. You already can specify. You specify by putting parentheses, right? Like, that is our specification mechanism that we already have. You don't want to introduce more. I just want to search for open paren not. That's not even a thing. How about in modules? No, okay. So like really, like The only case is this exact file that we're editing right now. This is not something that somebody has done in our code base as far as I know. But I don't really know, because there could be other things. I mean, there's not even that many squiggles in the whole program. Like, I don't see any kind of squiggle equation that's putting it. Flags might be wrong? What do you mean flags might be wrong? Why would flags be wrong? Is F signed or unsigned? F is a signed 64-bit number. Yeah, twiddle is usually flags. But if we change the precedence, that won't change the output of something like this. It'll just stay the same. Like unary twiddle in the absence of any other Boolean operators around it, changing the precedence won't do anything, right? I mean, unless you make it like tighter than dot or something, but then this just won't compile. All right, there's about an equal number of twiddles in here. Okay, so here's one where we say one left shifted here, twiddle, but that's how you would write it in C as well. So like, that's not going to change. Here, it's like, this is on the right-hand side, so that's kind of avoiding the ambiguity by just putting it there instead of on the left. I guess it, so that's actually, right, if you swap these two terms, it becomes wrong. So yeah, that's not good. The rest of these, yeah, I don't even really see this case come up. Which is probably, to be honest, why we didn't notice that the precedent was wrong, right? The precedence, because we literally never did it. Or like maybe if I did this one, like I wrote this, but this is probably the way I naturally would have written it. I could imagine a really long time ago, like at the very beginning of the compiler, I was like, look, I don't know what I want the precedence of anything to be, so I'm just going to put parens everywhere, right? But I don't even see any of that. Yeah, so I feel like I'm just going to change it. Let's go look at the precedence. I'll go over here for that. I think it's like get unary operator precedence. I think I might have stopped thinking okay. Tighter than bitwise ops, looser than array subscript. So I did that intentionally, and I think it was just, I wasn't thinking about it, right? Okay, so bitwise and bitwise or are the same. They're 3. So I think we make this 2. So we want not A and B to be equal to not A and B, right? That's what we're doing here. Okay. And wait, what? It didn't change it. Oh, you're right. That's a minus. Oh my God, there's no twiddle. Wait, what? Okay, let's put this back to 6 for a second. I was just squinting at the screen, and so I just assumed... All right. So it was literally getting a default of fucking 0. Which, wait, why was that? What direction do these go? So down is like looser. Lefty, loosey, tighty, righty. So... if this was 0, that would mean it's looser than bitwise, right? So we want to be tighter. Yeah, thanks for spotting that. Like, I was being dumb. Whoops. Okay. We want that. So we want it, we want right. You don't want like twiddle x sub 3 to be twiddle x sub 3, because that's nonsense. Like nobody's can use that to mean anything. So we want to be like 4, except these are 4. If I say twiddle x times y, what do we want that to be? I think it's twiddle x times y, right? It should be tighter than times. Or minus. Is that right? Oh wait, these are unary. Never mind. Hold on. These are, I was looking at the unary numbers. Those are all much lower, so we're fine. We're fine on that. These don't interoperate with each other because unary is syntactically unambiguous. They only can worry about these. So like 4 is actually fine. I feel like it's the same as unary minus. Yeah, no, you're right. It should be the same as unary minus, which we just made it. Actually, no. But unary minus actually could be 4 also. Like, because there's nothing, like, it goes 3 to 8 right now. So actually, these all can be 4, and who cares, right? in theory. We'll find out because I just changed it. Lol, 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 tra la 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 lol. Tra la 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 lol. Let's put that note. Okay. Hey, we changed the answer. Does the game run? Oh yeah, we're going to Benny test this, but first we're going to run the other tests. I'm just running the game in debug real fast. Hey, look, my guy is walking around still. That's great. It's wonderful. Okay. Can you succeed in the game industry if you can't get your Unity ops precedents right? Apparently, because this game is pretty good and we've been making it for a while with no problems. So I don't know what to say about that. All right. Change the operator precedence of bitwise unary whatever. It now has the same precedence as unary minus. So before this change, twiddle A and B is equal to twiddle A and B. This seemed unintuitive and differed from C as well. Now, twiddle A and B is equal to, wait, no, I wrote this wrong. It equaled to this. Now it's this, right? Yes. So, note that if you use the old precedents in your program, results will now change and stuff might break. However, this is unlikely to happen at the size of our current user base. Scanning both Sokoban, the modules and all our tests, we didn't see any occurrences of this construction, so we didn't make a meta program to search for it even, but you could do that if you want to be paranoid. Originally intended dereference priority. I don't, what? Most languages don't use the arrow syntax for C. Like, you're talking about very C and C++ specific syntax and then saying, is there any language that supports that? And it's like, well, other languages do other things. So it's not even really an issue. Like, I don't know of any other languages, except ones that copy C very, very closely, that use that syntax for dereferencing things. Like, the arrow is a stupid pain in the ass, and most languages have dumped it, including this one. Any tips on learning register allocation? Seems like graph coloring is the way to go. Okay, I have not written a register allocator yet, but I have read all about graph coloring, and I will tell you that I think it is complete bullshit that is representative of exactly what is wrong with academic compiler research. And I will tell you why. When you are generating code for a function, what you want to do is minimize spills, right? You want to say, hey, I want to keep all my values in registers. I have some fixed number of registers on this CPU, right? And if there are occasions where I would use more registers than I physically have available, or if, some of the instructions need things to be in particular registers, which happens on x86 to everybody's chagrin, then you do some code motion to make some availability, right? Okay, so that's the problem statement, right? Notice it does not actually matter how many registers you use, as long as you don't use more than the maximum, right? You don't get a reward for using the minimum number of registers. In fact, the registers are actually fictional on modern processors. They get remapped anyway. All right. Graph coloring, the entire conceit of graph coloring is that the answer that you want is what is the minimum number of registers that I can do, which is meaningless almost. It's, I suppose, not meaningless in the sense that if that number is low enough, you don't have to spill, and if it's too high, you do have to spill. But it's like, you don't care about the minimum. You care about not the maximum, or not more than the maximum. It's a different problem, okay? Now, the reason why I say this is typical of academic compiler bullshit is that people teach graph coloring and they get excited about graph coloring because it is a mathy thing that you can formalize and teach, regardless of the fact that it's basically irrelevant on almost every computer. That's what I think about graph coloring, with the caveat that I haven't actually programmed it myself. So, but really, if I talk about this kind of thing for long enough, I'll get really annoyed, because like, there's just a giant ethical breach being performed by almost all educational institutions currently. And that's part of it. It's like, sure, we'll teach some shit. We don't care. What do you mean we shouldn't teach it? We've been teaching this for decades. It's fine, right? And it's such a waste of time for all the poor computer science students. It's such a waste of time. If it's your first pass at the code generator, you'd recommend not doing register allocation to begin with. I agree with that. That's what I did, right? So we have been running for years now, because we have so much work to do, with our backend not really having a register allocator. Actually, I changed it. It has now a very, very weak sauce register allocator that's hardly even worth mentioning. But for years before that, we ran with no register allocator at all. We just wouldn't use registers. We'd use the stack. And it was a reasonable speed. It wasn't as fast as if you use registers for everything, but it was a reasonable speed. No more Quake. We'll pick up Quake in a little bit. I just wanted a little bit of a break from it. Graph coloring can be used to fill as many registers as possible, but you don't want as many registers as possible. That's what I'm saying. You don't want to maximize or minimize anything. You do not care about maximizing or minimizing anything. There is a step function where less than or equal to n is okay and greater than n is not okay. And there's no, as long as you're less than or equal to n, there's no gradient of how good things are. If you use 5 registers or 9 registers, nobody gives a shit. All right? Unless, okay, here's one exception to that. Unless you first generate machine code and then you inline later, and then you're like, well, this is more inlineable because it doesn't use registers that collide with someone else. But that's like not a good way to inline at all. So you shouldn't do that anyway. The idea is to minimize the number of memory accesses. Not in the accounts of graph coloring that I read. Maybe they were wrong. But there also, the thing to keep in mind is the minimum number of memory accesses on most modern CPUs is going to be 0, right? Or the minimum number of spills, right? So you need to read from memory in order to get the thing into a register. On most machines, you have enough registers, all right, for most things. Oh, I see. So you're not, yeah, you're saying what should be done. Yes. Okay, I agree with that statement. You want to minimize spills. That is what you're trying to minimize. You're not trying to minimize the number of registers, and that's a very different thing. And in fact, the statement that you're trying to minimize spills is probably an overgeneralization, right? What you're really trying to minimize is the amount of time you spend spilling and waiting on values to come in. And the thing is, that might differ depending on if you're loading a floating point value versus an integer value or whatever on a particular machine, right? And so that's, keep in mind that's an oversimplification, but to oversimplify, you're trying to minimize spills. You don't actually care about the number of registers. Does minimum number of registers not benefit hyperthreading because the 2 threads fight over registers? That's not how hyperthreading works, right? Like, so first of all, hyperthreading is kind of over for security reasons, right? But let's imagine for a second that it wasn't over. Like, it just pushes the register file. It's not like the other hyperthread knows what registers you care. There's no way for it to really know what you care about or anything. It just pushes the register file and makes its own active, right? That's my understanding of it. And again, keep in mind the register numbers that you use in your machine code on all modern out of order processors are fictitious numbers. They're not the real registers, right? On an x86-64 machine, you probably have substantially more registers available than you can address with instructions, and it just remaps them, right? So like, it kind of, like, this stuff kind of doesn't matter. And it never mattered, actually. I mean, there probably were some completely stack-based machines way back at the dawn of computer science where, like, maybe graph coloring could have been said to be relevant, maybe, because you were trying to minimize total stack space used by your program. But as soon as you have registers in hardware, it's the wrong thing. And the fact that nobody is saying, hey, why are you teaching this? It's the wrong thing, is banana nutballs, dude. It's like, it just shows how bad everything is. So even instructions that depend on specific registers are remapped. Yes. So in x86 code, if you say load a value into RAX, mul RAX by 3, store RAX into memory. That's just some register. It's not really RAX, okay? That's just some register that happens to be free right now. And what happens is the register remapping maintains the invariance that keeps that correct, right? What do you mean you don't have only 16 registers? Dude, I'm used to the days when we had like 5 registers that you could actually use. I'm used to the days when to do our texture mapper, you had to like store the stack pointer and then use it as a general purpose register because you needed one. Didn't know registers were so generic. Yeah, I mean, on very older CPUs, that's not true, but on modern CPUs, it is. It's just what they did to get more speed out of programs. CPU has more registers in the background. What do they get used for if you can target only a subset of them? Because, okay, so instructions, Casey has done much more thorough descriptions of this, including his members only stream from a couple days ago. So if you want a really involved discussion of this, you can go sub to Handmade Hero and watch the VOD. But basically, so instructions on a modern CPU have latency and throughput numbers, right? Throughput is like how rapidly can you run these instructions? Like how fast can you issue them and complete them, right? Latency is how long does it take between the issuing and the completion, right? And to have good CPU benchmarks, you want to minimize both of those numbers, but they are different numbers, right? Because there's a pipeline. There's like, you kick stuff off, some things happen to it, some other things happen to it, and those things take time, and there's data dependencies between them. And then at the end, it finishes, right? And so you don't want to wait for that whole pipeline of operations to finish. You want to issue more instructions before that one's done, right? And that's how all modern fast CPUs work. And so you need a lot of registers sitting around so you can like issue more instructions. Otherwise, you would just run out of registers and you can't like kick any more off, right? So that's why that's a thing. Yeah, yeah. In x86, you couldn't really use. I mean, you certainly couldn't use stack pointer and base pointer unless you did that. And then some instructions had to use A or D, right? Or SI or DI. Like you don't have a choice about that. So it was a pain in the butt. Yeah, I've never done 16-bit either, but I bet I'm glad I never had to do 16-bit. That was a little bit before my time. So I never had to do 16-bit. So you can issue 2 instructions on RAX that have a long latency, and they would both issue instead of the second waiting for the first to finish. Sort of. Okay, so you can do that. So if you use RAX, like your code still has to be correct, right? So if you load RAX, do something complicated, and then store it, and then right after that in your code, you say load RAX, do something else complicated, and then store it. Yes, all 6 of those instructions can be run in parallel, because even though you're using RAX for all 6 of them, the second load destroys the value that was being used after the first store. So the CPU looks at that and says, aha, there's no data dependency here. So this RAX being used for these first 3 instructions could actually be a different register than the one used for the second 3 instructions, right? However, if you keep using the same value and storing it in different places or whatever, then that can't really be 2 different registers, right? Because that would break your program. Shifts still need to use CL for dynamic amount, which is dumb. Yep. Yep. Yeah, what unexpected procrastination said is the case. Yes, they will get remapped. So that's another thing, by the way. What that also means is that certain kinds of like code motion that they teach in compiler class, like instruction scheduling, kind of doesn't matter anymore. Like your CPU does instruction scheduling now, right? Like you don't need to do it unless, I mean, there are certain architectures where it does matter because it's like they expect, you know, like the mill or something is like your compiler really needs to work hard to make things that'll run well on the mill. But for something like an x86 processor, like a modern, like an AMD Threadripper or something, your instruction scheduling doesn't matter at all. So if your compiler is spending time doing that, it's wasting that compile time, right? And if your compiler is full of code that does instruction scheduling, that's complexity budget that it is spending that is doing nothing. I mean, you could say there's some benefit still because, you know, maybe people are still running programs on like laptop CPUs from 1998, but the percentage of those is going down all the time. And for certain programs, you don't care about that at all. Is the mill still alive? I donated / invested in them like at the end of 2019, just because I felt like that was, I wanted to support projects like that. I haven't heard from them either. So I don't know. I mean, I have a feeling it's just sort of around slowly in the background, kind of going. Presumably lots of embedded systems compilers still have to care. That's probably true. Yeah. But also the good thing about those is you know exactly, like if you're compiling for an embedded system, you know exactly what that thing wants, right? It's not like the thing that's weird about like instruction scheduling in Clang or GCC or even Visual Studio is like, well, we're kind of trying to schedule for all CPUs that you might be targeting. And it's like, what? You know? You're into embedded systems and you've never done that. Well, I mean, we're talking about compiler internal stuff, right? I mean, I guess if you're writing assembly language, you could also schedule by hand. Casey in his subscriber only stream was scheduling by hand, but not to generate efficient output code, right? He was doing that just so he could understand how many cycles the thing would take, right? That's a different situation. Yeah, I don't know about the mill. I don't know if that's ever really going to be a thing, but I just wanted to support people who were doing really wacky far out stuff like that. Like just a different idea of how a CPU should work, right? Rate your setup. Am I going to click on a random link, image link? No. What I am going to do is go into security mode and send an email to the people or this one person saying fixed in the next beta. This is fixed in the next beta. Boom. 9 days after being reported, which is relatively long for one of these bugs, but yeah. Actually, I've got some from last Christmas. Dang it. All right. We'll look at this. We might, you know, it's going on midnight and I don't want to be up super late. So we might just investigate this one and not actually. Did I check in? Oh, we didn't do a Benny test. Let's do a Benny test. I should have done that while we were talking. Dang it. It is legit. Okay, let's see the setup. Wow. This brings back memory. I mean, I always used tower cases. I never had like a you know, mail order Hewlett Packard PC or anything. The Intel Inside stickers brings back memories. I mean, it's got a DVD drive and a 3.5-inch floppy drive. I mean, it's not that old. It doesn't have a 5.25-inch floppy drive. Isn't it kind of interesting how little keyboards and mice have changed relative to everything else? I mean, Apple tried to do weird stuff with mice, but it was all bad, weird stuff for the sake of being weird. That wasn't any good. Okay, here's the thing. Here's the thing, guys. I don't see a turbo button on this PC. So it's not that old. It's not old enough to have a turbo button. Turbo was gone by 46. It was still around. It just didn't do anything. Like you had this thing for a while where like people didn't want to sell cases that didn't have turbo buttons because you might think that if you bought someone else's case, your computer would go faster, right? So like I definitely had PCs that had placebo turbo buttons on them. 3366 7-segment indicator. Yeah. Oh man, I remember that. It was like, I guess that was just like a way to brag about your CPU or something. It's a Pentium 3. My first computer was a Windows Vista machine. Ooh, sorry about that. Done already. Yay, okay. So we certainly didn't die, and we have the right number of fails, so that's great. So we are gonna check in this. Boom. Okay. Let's just look at this last thing, and I honestly may not do it tonight. Wait, why do I have so many of same folder? Stop. Okay, so downloads, proc program param. Extract all. Okay. Replace. Okay, so let's see. Unable to find a wait, where? So it's, do I want to say dot? Let's see. Okay. Redeclaration of some param. Is that what is not what the user reported? Redeclaration of some param. Try to use a procedure. The small program, when you try to import my module, you get errors complaining that the module parameter is redeclared. Interesting. Why would that happen? It's like he's saying this only happens when there's a procedure parameter, which sounds to me like a yielding problem. It sounds to me, Okay. Infer module parameters call. Yep, okay. Okay. Module parameters. Okay. If which will cause a redeclaration error if we yield later and come back and do this again. Let's say do this only once. It sounds more Chad-like. All right, so true. Okay, that's a little bit. Can continue, right? Because we scoped it. Why so many windows? Chill windows. Chill. Like, we don't need this. We don't need this. We don't need chat. Okay. Hey. Hey. You know, I said maybe we'll just look at it. But we fix it. Boom, fixed in the next beta. Boom. Fixed redeclared variable, or what did it say? I don't remember what it said. Fixed redeclared variable errors when module parameters used relatively complex data types as arguments, such procedures. That's like actually enough to deliver value to the people, but we're not gonna, because none of these are like super critical for anyone. So we're just gonna hold off and not give beta fatigue to the people. See, that's the kind of thing where if you wrote the system or you're just well educated in it and you know how it works, that did not take very long to fix it all, because I had a very good idea what causes that kind of problem. Somebody, if like I was making this compiler as a job and then I quit and someone newer on the team had to replace me, how long would it take that dude to figure that problem out? and like to know what's a reasonable solution. Probably hours to just like understand what's going on, at minimum hours. So like there's just passing on this kind of knowledge is very important, and it's the kind of knowledge that doesn't get passed on very well. Found a picture of your setup. Oh, I think I had that monitor on something. Intel Inside. Oh, you had the media buttons on your keyboard. Look at that. Email. You have the email button. The email button. You also have an open case. All right. I'm going to sign off. Let's see if there's anybody programming at midnight that we can twitch.tv/science and technology. Adam C. Eunice, we could go to him. We haven't gone to him in a long time. People who put their editor in the title, I just don't go to those people. I'm sorry. It's just how I am. Ask your game dev questions here. Computer Chronicles. That guy looks very... He looks like the boss from Office Space almost. Battle Royale mode incoming. In what, though? Okay, these guys don't look like they have anything yet. So we're not gonna like raid early discussions about what should the game be. We'll go to Adam C. Eunice because we haven't gone to him in a long time. All right. How do you do a better job passing knowledge? Is it just a matter of better documentation? Documentation helps, but it's a lot deeper than that. Wait. I didn't select the whole name. All right, thanks everybody for coming by. And we'll see you later.